Subject: Material Science and Metallurgy. Practical number 8. Aim: to study stages of tempering. Tempering. Quench hardening produces structure, martensite and retains austenite. The martensite formed in quench hardened steel is exceedingly brittle, hard and highly stressed. The cracking and distortion of the hardened article is liable to occur after quenching. For this reason, the use of steel in this condition is inadvisable except in case where extreme hardness is required. Secondly, quench hardened steel besides containing martensite has some retained austenite too. Retained austenite is also an unstable phase, and as it changes with time, dimension may alter. For example, dies may alter 0.125 mm. It is therefore necessary to return towards equilibrium after quench hardening by heating hardened steel to a temperature below the lower critical temperature. Even this is tempering. Tempering requires heating hardened steel below the lower critical temperature, holding it that temperature for 3 to 5 minutes for each mm of thickness or diameter, cooling the steel in water, oil or air either rapidly or slowly except in case of steel susceptible to temper brittleness. Stages of tempering. At low tempering temperature approx 80 to 200 degrees Celsius, a hexagonal closed pack carbide called epsilon carbide begins to form, and with this rejection of carbon, the crystal structure of martensite changes ultimately from tetragonal to the body center cubic characteristic of ferrite. The second stage is at about 200 to 300 degrees Celsius, depending upon the steel, is characterized by transformation of the retained austenite to bainite. During the third stage, from 300 to 475 degrees Celsius approx, there is formation of Fe3C cementite from epsilon carbide and exchange from low carbon martensite to cubic ferrite. Or from 450 to 750 degrees Celsius approx, the cementite Fe3C agglomerates and coalesces. The structure becomes an aggregate of ferrite with cementite in quite fine here, referred to as tempered martensite and tempered bainite. Martempering. In martempering, steel is heated to above the theoretical range to make it all austenite is then second quenched into a salt bath maintained at temperature above the ms and is held at this temperature long enough until the temperature is uniform across the section of the workpiece without transformation of the austenite, and subsequently cooling the workpiece in air through the martensite range. Here the martempering figure is shown. Left side it is temperature shown MF and MS. Right side on x-axis it is time shown. The result is the formation of martensite with a minimum of stress, distortion and cracking. The steel thus obtained may be further tempered in order to increase ductility. Large section cannot be heated by martempering because the time required to obtain temperature uniformly exceeds the start of the transformation of austenite into bainite. Actually, in practice, in order to utilize benefits of martempering, alloying elements are added to steel. Otherwise, the critical cooling rate is too fast and the benefits of the martensite hardness cannot be realized in parts that are larger or even medium in size. Thank you.